In the last video, we discussed industries based on using minerals in their native forms as metal oxides in oxide industries. And in this video, we'll move to the extractive metallurgy production of metals. So typically, as we said previously, metals exist in ores. Sometimes they will exist as pure metals, but this is not very common. It's only for precious metals like gold, silver, platinum, and so on. But for other metals, they typically exist in ores that are oxides, sulfides, or different salts. And that table here gives us the most common minerals for each metal. Aluminum usually exists in gypsite as bauxite mineral, which is aluminum hydroxide, barium in barite, which is barium sulfate, and so on. We discussed previously how to go through the mining steps to collect the mineral and move it to the production step. Before production, there are a series of steps to prepare the raw materials for production. That includes concentrating the mineral using magnetic attraction, flotation, or leaching to make sure you have a higher concentration of the element of interest, and then pre-treatment to convert the mineral to a compound, a specific compound of the element of interest. And that includes pyrometallurgy using roasting and hydrometallurgy using solutions. Once you have a pure precursor of the metal, you can put it into the extraction step, converting the compound into the target metal. And that usually is done using chemical redox reactions or electrochemical redox reactions in some cases, as we will learn later. Once you reduce your metal, you will put it into a refining step to get rid of the impurities using electro-refining, distillation, or zone refining. And finally, depending on the application that you want metal for, you can either use it as the pure metal or make alloys of that metal for different applications. The ore concentration, as we said, or sometimes called the ore dressing, and has the aim of increasing the amount of metal in the ore and get rid of any other products that will not produce the target metal. And that includes crushing the ore and grinding it, then concentrating the metal by separating it from other components in your ore. Several techniques are used for that separation purpose, including gravity concentration that depends on the different weights of different components of the ore, flotation techniques, and magnetic separation. Gravity concentration is simply based on the weight of the ore, whether it's heavier or lighter. If the ores are heavier than the waste, you will shake them while wet, and the particles of the ore of interest will separate into layers based on weight. Metal-rich layer can be removed as a layer out of the other waste. Flotation uses a similar technique. However, you enhance the separation using a stream of air that blows into a suspension of the ore. Air bubbles will carry lighter particles into the froth that can be collected or skimmed from the surface of the flotation chamber. And sometimes you can enhance that flotation technique by adding detergent and oil so that the oil-water separation will help with separating particles from each other. Finally, magnetic separation is usually used for magnetic ores or ores with magnetic properties. So you grind the ore and pass it over a rotating drum that has a magnetic side. So it will have different attraction for different particles depending on their magnetic properties. The magnetic particles will be attracted much more to the drum than the non-magnetic particles. So it will have a different path that will separate the magnetic particles from the non-magnetic particles. The second step is going to be pre-treatment. That includes converting the ore to a certain compound of the metal of interest, and that can be achieved using two techniques: pyrometallurgy, or sometimes called roasting, in which the minerals are converted to oxides specifically, because oxides are much easier to reduce, and that can be achieved by just heating up the ore. In this case, whatever form of metal salt the ore will contain is going to decompose to make the corresponding metal oxide and expel the other parts of the salt as gases. Sulfides will do the same thing. When you heat them up, they will convert to oxides by reacting with oxygen and expels the sulfur component of the structure as sulfur oxide gas. Another possible technique to achieve that is hydrometallurgy or leaching. In this case, you dissolve the ore as a soluble salt in a certain solvent, and that usually uses acids and bases. So acid leaching will include dissolving the ore into different acids, sulfuric acid and hydrochloric acid mainly, to produce the corresponding metal salt. Basic leaching include dissolving in a base instead that will again produce a soluble form of the metal. It's possible to achieve this using oxidative leaching with oxygen and acidic medium, and sometimes it's possible to achieve this with complex leaching. So you use a complexing agent, a ligand, to dissolve your ore into a metal complex, a soluble metal complex of that metal. After the pretreatment, you will take the metal compound that you obtained and put it through an extraction step, which is typically a reduction step that transforms the metal ions into the reduced metal form. This reduction step can be achieved using several methods depending on the purity of the starting material, the energy requirement needed for the reduction to take place, the cost of the reducing agent, and the position of the metal in the reactivity series. The reactivity series determines how reactive your metal is and how possible it can be extracted or reduced. All the metals that are below hydrogen are less active than hydrogen, so they typically could exist as noble metals in nature. All the metals that are above hydrogen but below carbon in the series are less reactive than carbon, so they can be reduced with carbon or carbon monoxide. All the metals that are above carbon are more reactive than carbon, so you cannot use carbon to reduce them. And in this case, you have to use other forms of reduction chemically, or most likely you will resort to using electrolysis as a reduction method in this case.